Welcome back on the Friday evening. We are going to do another problem for homework 1. This time we are going to try to do a similar problem to problem number 3. Okay, so in this case you see this little triangle. Don't be too scared of this little triangle. This is the so-called op-amp, operational amplifier. The positive guy is called the non-inverting input. Okay, so this is the non-inverting. Let me call this non-inverting. Okay, and this is called the inverting. And as you remember from your previous studies, that the op-amps are used as summers or integrators and differentiators and so on and so forth. So this is the inverting. And if we put this to ground, this is like a virtual ground, and the impedance of this op-amp is so high that hardly any current goes in there, so the current will take this path. But getting back to your problem here, so in this problem what I like to do is I like to connect two components here, one resistor in parallel with the capacitor. Let's put it right here. We're going to call the resistor as R1 and the capacitor as C1, and here what we have is the input VI, and at the output I am going to put two of them in series here. So let's R2 and call this guy C2. Okay, and this will be your output. Well, your homework problem says you're supposed to find the transfer function. So my friends, the transfer function is going to be equal to what? Recall that, V out of S over V in of S. That is your transfer function. Well, how do you do this? Interesting question, right? So first of all, let me use a different color here. Let me use a red one for this guy. We are going to call this block as Z1 of S. Okay, and let's put this as a green block, and we are going to call this guy as Z2 of S. Well, you know, if you recall, Z1 and Z2 of S, both of them are impedances, right? So let's compute or try to solve for Z1 of S. Let's keep it color coded here. So Z1 of S, well, in Z1 of S, if you're trying to compute that, it's pretty interesting here, right? Because this is in parallel with this guy. So if you recall that for the capacitor in frequency domain, this is equal to 1 over C1 of S, right? So, and then they are connected in parallel, so we can pretty much say this is equal to R1 in parallel with 1 over C1 of S, right? So if they are, then I can pretty much write this like 1 over Z1 of S is equal to 1 over R1 plus 1 over C1 of S, isn't it? Right? So that will be equal to, a little bit of algebra there, 1 over R1, so kind of flip this over, this will become C1 of S. Hey, that is 1 over Z1 of S, isn't it? So to find Z1 of S, all you gotta do is, you can even cross multiply and bring it down here, right? So this will be equal to 1 divided by 1 over R1 plus 1 plus C1 of S. Not that bad. So to make your life very simple, what I am going to do is I'm going to give them the value of 1. I'm going to call this 1 ohms. So R1 is equal to 1 ohms, C1 is equal to 1 farad, R2 is equal to 1 ohms, and C2 is equal to 1 farad. Makes our life easier to solve this problem. So again, it is color coded, so let's keep it like that. that is going to be equal to s plus 1, because C1 is 1, R1 is 1, so it's 1 over s plus 1. So we are done with Z1 of s. So hopefully this stays less than 10 minutes. So Z2 of s, as you can see, they are in series now, so that's not that hard. So Z2 of s should be simply equal to R2 plus 1 over C2 of s. So, as you recall, we said, well, R2 is equal to 1, so this will be 1 plus 1 over s. So that will be equal to, my friends, s plus 1 over s. Well, I lost my color coding with the green, but that's fine. We'll make it black and red now. So V out over Vs, V1 of s, or V in of s rather, will be equal to Z2 of s divided by Z1 of s. Here you go. So now Z2 of s will be equal to what? S plus 1 divided by s, and the whole thing is 1 over s plus 1. Well, do a little bit of algebra again. Just flip this damn thing over. This is going to be s plus 1 whole square divided by s. And here you go. So you have the answer. S squared plus 2s plus 1 divided by s. That is the answer to that problem to find the transfer function of the given circuit. Transfer function. So this solves the problem number 3 on homework number 1, and I'll see you shortly in the next video. Thank you.